Hi, everyone. My name is Emanuele Libralato. I'm a senior software engineer here at Garden, and my background is kind of a full stack engineer. And nowadays, I'm focusing mostly on our cloud offering. And today, I wanted to talk about Docker Compose and essentially how its concepts, primitives, and configuration map to Garden. But before we start doing this, I just wanted to give you a bit of context why we're doing this. And essentially, we've been talking with a lot of our prospects, users, or in general, with a lot of cloud native developers. And lots of them are starting to have, or they report that they're having a kind of a subpar experience with Docker Compose. And the recurrent pain points that they told us during these conversations essentially can be summarized in three main areas, if you allow me that term. So so some of these areas are essentially scalability. So a lot of them they use Docker Compose because it's very easy to get started. But when the project starts to reach a certain size, let's say 10, 15 services, it really depends on the term they're using, but that's kind of the size that I have in mind. It starts to become difficult to reason about dependencies, to understand how to run all the services, or even actually just to run all the services, because again, you're running things on your local machine, and if you're using certain languages or certain applications, it might be just not possible to run your entire stack, your entire microservices application in your machine. Another thing that people complain a lot is what we call the configuration drift. Essentially, a typical setup that a lot of teams have is developers will have their Docker Compose setup on their dev machines. But then once the changes have been made and the PR is created, or the code and the application moves to a different environment, and this environment is usually managed with different technologies, like, for example, Kubernetes. And that creates the kind of works on my machine problem, where you maybe set up your network in a certain way, or your service is configured in a certain way to work on your local machine, but then when it goes to production, it breaks, and it just makes everything super complicated to kind of reason about and to debug it. And finally, the testing story for Docker Compose is not very well defined, especially around integration tests, end-to-end tests. And most of the dev teams that we spoke about end up like relying heavily on CI systems, which again slows the feedback loop while you're developing, because you have to, a typical use case is you make your changes, you fix a bug, you make a new feature, you run your unit tests in your machine, then everything else is run in CI, and then you suddenly discover that you broke a downstream service, and you have to go back to your local environment, make changes, and rinse and repeat. And this is kind of frustrating for a lot of these people. And so, yeah, so what we're going to do today, you mentioned the use case, you're using Docker Compose, you want to kind of tired of all this issue that we just described, and you want to try a different tool, and you ended up on the garden.io website, and you want to see how Garden can actually help you fix these issues, or kind of overcome those challenges. And what we're going to do today, we're going to try to migrate a project from Docker Compose to Garden. I chose a kind of sample project from the Awesome Compose repo. It's kind of a collection of Docker Compose examples. And hopefully by the end of this brief talk, we're gonna we will understand what are the primitives and concepts of Docker Compose and how they match to Garden. And yeah, let's just dive in. I'm gonna stop sharing my my slides now, and I'm going to go to my VS Code. So just gonna go an overview of the project here. It's a It's again a very simple project. It has a React service. It's a to-do list app, so it has a React service that runs using a Webpack dev server. It has a proxy server to a backend, which is an Express server that essentially retrieves and stores to-do items from a MongoDB. Can go briefly to the Docker Compose file. It's again not too complicated. So it defines 3 services and 2 networks. First one is the front end, exposes port 3000, mounts the local source code to the current Docker container that is running. Container name is Frontend. He has a React Express network, and it depends on the backend. Backend configuration is fairly similar. Again, just change the name and as well mounts the volume on the running container, depends on Mongo, and has access to 2 networks and expose port 3000. And the last service is the Mongo service. In this case, we don't have any Dockerfile or source code. Anyway, how was your day? Oh, total waste of time. It's just taking the image directly from Docker Hub, I suppose. And there's a volume where we essentially persist the database data, access to this network, and exposes this 27017 port. So I have it right here. So I run a Docker Compose app, and what it looks like is essentially this wonderful to-do list. He just added to do here, retrieves the to-do, doesn't do a lot. So yeah, so let's start to bring Garden into this project. So the first thing that we need to do for Garden to be able to do anything with any project and any source codes, we have to create a project configuration file. So we're going to call this project YAML. Copy it from my machine, and a project configuration file looks something like that. So we have, it's a YAML file, can be called anything as soon as it ends up with garden.yaml. We have a kind that we set to project. We're going to give it a name. We call it compose to garden. And a project usually has 2 other important sections. One is the environments, where we can define multiple environments. We're going to just create one and call it default, and a provider. And in this case, we're going to use the local Kubernetes. So the main difference between the kind of Garden setup and Docker Compose setup at this point is that Docker Compose will just create the kind of these sub networks for and will run all the application on your localhost to achieve the same kind of same setup. With Garden, I decided to just go with the local Kubernetes because it's the simplest configuration that we can think of, which means I have to have a local Kubernetes cluster running, and yeah, that's the main difference for now. I'm gonna explain later how that influence like the various configuration, but we're using the local Kubernetes provider for this example, but potentially you can use any Kubernetes cluster that you might want to use. And for example, internally at Garden, we all develop remotely, so we use a dev cluster that is shared between the entire development team. So yeah, so we have this file, we saved it, deploy, see if it's a valid file, it should be, and it's going to just getting the status, the provider status, and then it should just abort because of course there's nothing to deploy yet. We haven't configured anything else. So let me just put this aside here. So the Docker Compose, it seems like based on the dependency structure, is that the first service that needs to be deployed is the Mongo one. So let's go ahead and create a just gonna put it in a folder, keep things tidy. On the side. Configuration that I prepared. Here we go. So one important abstraction or kind of primitive of Backend is the concept of a module. A module is a kind of a unit that can define multiple services as well as tasks and tests. So if you want to deploy something, you have to create a module. And within the module configuration, you can then define how the thing that we want to configure, we want needs to be deployed, needs to be tested, or if there is any task that we can define with this source code essentially. And in order to do so, we have to define a kind of module. Module is a little description that we can set. So MongoDB for storing to-do items, whatever. And we're going to use a module type container. So what this means is that Garden is going to try to build a Docker image, fetching either an image that we can define like this, or picking up the image from the folder where the Garden YAML resides. And it's in the case, since we're using local Kubernetes provider, when it's going to try to deploy in a Kubernetes cluster, it's going to create for us a kind of a service and a deployment resources, and then kind of deploy those resources for us. It's a very good module for starters because Garden takes care of kind of creating a good enough resource that you can start playing with. But of course, if you need a little bit more fine grain and more control on what you're deploying, we have also, for example, module type Kubernetes, where you can define like all the Kubernetes resources that you might need, or additional settings that you want to tweak. We also have Helm chart where you can use your Helm charts to deploy stuff and so on and so forth. So, but for this example, we're just going to stick with a container because it's simpler and works well for what we have to do. We're going to give a name, and then we can define services. So for the services, we create one service called Mongo, and we define a volume. We're gonna go back here in a second, and we expose the port. We create a port called DB, and this is the container port that we're gonna expose. Regarding volumes, the main difference with this configuration here, the Docker Compose one, is that in here, what we're saying essentially is we're going to mount the local DB folder in the container. And this is done essentially to allow the persistence of the data that has been saved on the database. This works very well because everything is running localhost, but in our case, we are running in a cluster, and this is not something that is really possible. So to kind of keep the a similar configuration, I created a module the same way that it is created in Docker Compose, but it's not equivalent. If we want to have a persistent volume that, so this is going to create an ephemeral volume essentially. If you deliver deployment, it's gonna, all the data that you saved in there, it's going to disappear. If we want to create a persistent volume, there are different ways of doing this. We have a module type for that's called persistent volume claim module, and that will create a persistent volume claim resource on the cluster, but it's kind of outside of the scope of this presentation, and we're not going to dig deep into that. And as well, it's never a great idea to anyway have your the actual storage of your database running in as a Kubernetes resource, unless you really know what you're doing. So we're just going to stick with this, and it's kind of fine for this demo. So we created our Mongo module, Mongo service. We're going to try to deploy it now. Let's see what happens. So now Garden is going to go again inside the project. It's going to find that there is a new module, and it's going to deploy it. And this is done. It's got deployed. If we do Garden logs, we should be able to see a bunch of interesting logs. Great, looks fine. Yeah. And so now we have a running database. Next, we're gonna say again, following this dependency structure, we're gonna create a backend Garden configuration. Pick it up from here. So again, very similar to what we just did. We have a kind module. We're going to give it a name backend, show description. We're going to use the type container because it's good enough for us. We're going to create a service and call it backend. We're going to leave this commented out for now. We're going to go back at it later. And now what are we going to do? We're going to set up a port. So we're going to expose it through port 3000 of this container. Of this pod in this case. We can set up a health check for Kubernetes to make sure that this thing is always up and running. And in this case, we are setting a path for an HTTP GET as a health check, and we're using the port that we just defined up here. And he has the dependencies on Mongo, and we can also decide to expose it to through an ingress. In this case, we're saying use this path, use the port we define up, and this is the host name that we're going to expose this. You can access it from. In here, I'm using a template strings, which means if I can define variables in my Garden configuration files. In this case, I created a variable for this environment. And what I'm saying is the base host name for this, the base host name variable is composed to garden.local.app.garden. I chose this host name specifically because whenever we deploy on local Kubernetes, Garden will use these as a default host name. We will use the name of the project dot this local.app.garden as a default host name. And this is essentially a DNS utility that we have that will just point back to localhost. So essentially, if you go through this, it's going to go to localhost and to the cluster, to the local Kubernetes cluster. So I'm going to save this. So here, essentially, I'm saying expose the backend service at this hostname, which is backend.garden to compose to garden, blah blah blah. And so yeah, this looks good. Let's try to deploy it. It's gonna get the backend. It says already built because I've been building it already earlier, and Garden is kind of smart enough to understand if anything the source code has changed, is gonna rebuild the container. Otherwise, it's just gonna use the image that's been built earlier. And now we can go to this ingress. There's nothing in the root, but if I go on the API, it's just gonna return the API response without data because we haven't inserted anything yet. So we're going to do now the same for the front end. And this is going to look extremely similar to the backend. We have our module name front end, show description, type container. Exclude the not modules because we don't want to sync it in the container. And we're going to create a service called front end, and then we're also going to set an environment variable called dangerously disable host check. So the reason for doing this is because in this example, the front end server is a Webpack dev server, which will check if the host name is what has been defined in the source code, which in this example, I think is localhost. So if I try to start a Webpack dev server that has localhost as a host name, but in a different host name, and I reach it from a different host name in the browser, it's going to complain and not work. So we're disabling this host check because we are reaching from the compose to garden.local.app.garden. And of course, this is just for development. And then similar to what we did earlier, set up a port, call it HTTP. We expose the 3000 port. We set a health check on the root, and we have an ingress on the root, again, using this port. And this is a dependency on the backend. I'll deploy this. This is going to take a bit. Here you go. Now it started. And we have our app running. So and we can add them and do add to-do list to our application. So one thing that Docker Compose is pretty neat is that since it's running locally, and you can mount things in the running container from your host machine, it allows you essentially to do something like hot reload. So if you go, for example, in the React app, you say my to-dos, you see in here it's just recompiled because he saw that there were changes, and Docker Compose one running on localhost, you will just immediately see the changes, which is pretty handy especially if you're doing front-end development. So how do we reach the same with Garden? In the front end, we change the front end.garden.yaml, and we have something called dev mode. Essentially, where's the Docker Compose file? It's a very similar kind of syntax of how you set up volumes. But what we are doing, excuse me, what we're doing here essentially, we're saying we are going to sync the source folder in the target pod, and we're going to use this mode. We have different modes, but one way replica will work for this. And the way that this works is now we have to use a different command called garden dev. And what garden dev is going to do is going to redeploy the front end with a sidecar essentially that is responsible for syncing our source code. It's going to take a second. And we should be able to obtain the same result. So again, it's redeploying because it just the old deployment didn't have the sidecar that I just mentioned, so we just tear down the deployment and redeploy the service. 1 second, should be done. And here you go. So now we're syncing this folder in the remote deployment, remote deployment, and we can, the version is going to look like the Docker one, but we can now go back and change use. I'm going to obtain the same result. And yeah, so at this point, we kind of reach a feature parity between Docker Compose and Garden. A couple of things more that Garden allow you to do. I'm not gonna just go too much into details, but a module, as I mentioned earlier, allow you to also define tests. So you can say, for example, I want to run my end-to-end test, and I want to have the dependencies on Mongo and Backend. So I can just save this file and then run Garden test. And is going to make sure that all the dependencies of this test are up and running. Well, in this case, so test. Yeah, so it's just going to redeploy the dependencies and make sure that they are up and running before actually running the test. And I can do the same also with task, for example. So I can define a task as like, let's say that before running my end-to-end test, I want to seed my CI database and just run Garden task seed. And I'm gonna seed my database, then I can run my end-to-end test, and I can do all of this while I'm developing. So without waiting for CI to do this operation for me, I can just do it while I develop, because my application is actually running the same way as it would run in production staging or whatever. And this is kind of extremely beneficial because it's one of the problem that I mentioned earlier. So having a slow feedback loop kind of disappear in this way, because I can run the same test that I run in CI while I'm developing. And yeah, I think this is mostly it, really. Yeah, is there any question?
There was asked a question in the chat there.
Oh, sorry, I was not looking at the chat. Can Garden dev mode plus Garden test be combined? Like running some unit integration test on reload? Yes, you could potentially do that.
That's what Garden dev does by default, actually, at the moment.
Yeah.
I
I'm just wondering if you actually want to do that, because I mean the sync mode will actually just sync at every save, essentially. So
yes, and essentially that's what I'm wondering, whether it's possible in the same way that if you were running Webpack dev server locally and you saved and it reloaded at the same time, it could kick off something that's watching those files for changes as well, that could, like, you know, double check your unit tests or lint or something, so that it's making sure that either before it deploys or at the same time as it's deploying, that you'll catch, I don't know, some lint fail or a unit test fail.
Yeah. So this dev mode configuration is extremely basic, but I think you can specify a command which will
That's
command.
not at the moment. There is I think there's an open feature request to run a command post sync.
Yeah,
But yeah,
no, I was not thinking about the post sync. I was thinking about you can override what the dev mode container runs as startup. So in this way, when you run Garden Dev, we will redeploy the container and run the same, essentially the same entry, the same command of your Docker file. But you can override this to.
Yeah, so if you had npm run dev or npm
yeah,
test and npm run dev or
yes,
something in there, that would
cool. Stuff like that. So it really depends from the stack that you're running, but there are kind of a couple of options there that can help you out in that.
Yeah, and Garden Dev can also just run like other test specs, but it will probably be more efficient to do it from within the container, like with a sync. The only thing I would mention, that command is actually a level above, like next to the sync center.
Yeah, fair enough. Yeah.
But yeah, that's pretty straightforward.
It's not something that I reconfigure often, so I forgot where it is.
Yeah. Can't wait to get the autocomplete support in there. We're sort of iterating towards that. That is quite nice.
Yes, absolutely.
One thing I'll just interject into there is, like, when you're writing integration or end-to-end tests with Garden, you can you have all the stack running, and you can get sort of a unit test like workflow when you're using dev mode and writing integration and end-to-end tests. We do that quite a lot ourselves.
Mm-hmm. Yeah, I guess another remark as I was observing is, I mean, we have looked into like just doing automatic conversion of Docker Compose files. A couple of reasons why we haven't done it yet. One is that there are some variations on how you might want to translate or sort of project the two different configurations. So like, some people will want to turn it into Kubernetes modules directly. Some people will want to turn it into container modules. There are, some like sort of stylistic differences in how things are set up. So it wasn't always like a completely obvious one-to-one mapping, but it is still something that is on the roadmap. But I still, for this here demo, it's actually, more useful to just see, like, kind of walk through like what's actually, how things kind of map to one another, and see it done sort of like step by step, as opposed to, less of a demo if you just like run a script and it's done. I mean, like it's a pretty snappy one, but like I think it's important to understand sort of the sort of semantic subtleties and everything that comes about, like especially like with volumes and all that stuff. But yeah, no, just wanted to mention that that's something that's always sort of in the back of our mind, like how can we ease that transition like that, and still an open issue for it out there.
Yeah, I also didn't talk a lot about the networks. Essentially, in the example that we deployed, we're just using the internal namespace network and the DNS resolution of the namespace. But also that if you have like a complex structure there, it can be kind of tricky to translate into Kubernetes resources. You could have a full-blown talk of 2 hours about Kubernetes networking. So
yeah, I think like in most of the scenarios where we see transitions from Compose to Kubernetes, the networks part is quite often just dropped. And it's just, it's a feature that, like, if you have Docker Compose, you might want to use it, but it's fairly, like, we don't see a lot of it in real life Kubernetes usage, outside of just like having like different projects and different namespaces, of course, but
yeah,
but that's a different story.
Yeah.
So to Albert's question there, in the we should get to the next one as well, though. But just because this is something that's on our plate in the next 2 weeks. You can of course run local services with Garden using the exec module, but we are going to be implementing sort of a telepresence-like feature where you can, basically a locally running service can receive traffic from, inside the cluster as if it were inside the cluster, but run locally and iterate on it that way. So
Could we maybe
currently
repeat the question for the sake of
so he asked, like, does Garden support some kind of hybrid workflow, for example, running an app locally but tunneling networking from and to Kubernetes, thus giving you the best of both worlds. And so, the problem, one of the things that telepresence is aimed at solving is the bi-directional part of it. It's easy for you can configure a local service to be authenticated to send requests to the backend, but for example, if you have a login flow and the login flow has to send a token back to the front end, those things can get awkward if you don't have the bi-directional communication. So we had looked at just the telepresence with Garden Story, but just it's a bit heavyweight, and the sort of the magic that it does in terms of the annotations and so forth doesn't play nicely with our deployment model. So we're kind of rolling our own lightweight, high performance sort of quick solution to that. So that's going to be coming out in the next 2 weeks. But yeah, plenty of people do local development, hybrid development with Garden currently, but this is kind of specifically enabling the case where you need to be able to receive traffic back from the cluster.
And just to also answer Louis' question, we do not have a Nixos package for the Garden CLI. Do we have anything planned for that, Yo, or Dr.?
I think it's come up once. I don't mind it. It's just hadn't gotten to it yet, but there's nothing to prevent us from doing that. It's just would love to see a GitHub issue or like a feature request for it, and then it's I'm no doubt like pretty easy to do.
Yeah.
And of course, we are on Homebrew.
Yeah. All right. Are there any other questions? I think we're good then. I just put a couple of useful links. So there is the repository that they just showed you. It's on our Garden IO organization. It's called Garden Docker Compose. And yeah, if you want to check the docs or want to reach out in our community, just feel free to do so. Thank you very much.
Thanks, Emanuele. That was good.
Thank you.
Thanks.
Emanuele.
Thank you.